So my aim here is how to find the second derivative of inverse circular function. Now, as you know, the first derivative, that is y suffix 1, that can be calculated by just operating ddx on a function y. So you will get dy dx. Now the second derivative, y2, y suffix 2, is nothing but operating ddx on dy dx. Then you will get y2. And that y2 is represented as well as by d2y by dx2. Now, second derivative problem, different types of functions are there, but just now we are operating on inverse circular function. Now, inverse circular function, as you know, it is just an angle. An inverse represents an angle, like tan inverse x, sine inverse x, cos inverse x, and so on. Now we will here just understand what is the first derivative. Firstly, that is to operate ddx on some inverse. Like if you operate ddx on tan inverse x, the answer is 1 by 1 plus x square, as well as the ddx on sine inverse x is 1 by root over 1 minus x square. And I will show you now I will show you the derivative of all the inverse here, starting from sine inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. Now you have to remember this formula. So 1, 2, 3, 4, 5, 6. 6 formula you have to remember. At least 4 formula is very important. Now the first formula, sine inverse x derivative. This is the ddx is the operator. ddx is the operator. So the derivative of sine inverse x is 1 by root over 1 minus x square. So you write down in your copy. And ddx of cos inverse x is the same thing, 1 by root over 1 minus x square with a minus. Just the difference is that it has a minus, cos inverse x. Now ddx of tan inverse x is 1 by 1 plus x square. And similarly, the derivative of cot inverse x is 1 by 1 plus x square along with the minus. And similarly, you can see these also. So you have to remember the first derivative, that is when you are operating ddx, on this function, you are getting this. So that you are getting is something like, you can say dy by dx. Now what is this? Dy by dx is nothing but y suffix 1, and that is the first derivative. First derivative of sine inverse x, 1 by root over 1 minus x square. And similarly all this. So these are all our first derivative, that is y1. But what is my target? My target here to solve the y2 problem. Y2 problem means second derivative problem. Now you have to prove something, and in each problem we will see that you have to prove something which carries this y2, carries this y1, and you have to prove that. I will give you an equation and you have to prove that. That means you have to find the derivative, first derivative y1 first, and then you have to find the second derivative. But in the problem, you will see there is some technique by which you will have to solve those problems. Now I will show you those things. So firstly, I'm telling you to recall this formula, and then I will show you how to find the second derivative. So now I am coming to the second derivative problem. Now you will see 4 problems there. Number 1, tan inverse problem. Number 2 is a sine inverse x problem. And thereafter 2 problems I am taken of the same category, tan inverse x and sine inverse x, but you will do it yourself. So firstly, I will make you understand how to solve the problem number 1. So here you see y is equal to tan inverse x. And you have to prove this thing. 1 plus x square multiplied by d2y by dx2. Now you see y1 is nothing but dy by dx. And y2 is nothing but ddx on this dy by dx. So you are operating ddx on this first derivative y1 and you will get y2. So when you are operating ddx on y1, you are getting y2. And this also you can write in this way also, d2y by dx2 by d2y by dx2. I'm writing it. So you see d2y by dx2 is nothing but y2. So what is y2? y2 is nothing but d2y by dx2. So this d2y by dx2 is y2. So here 1 plus x square into d2y by dx2 plus twice x into dy dx is equal to 0. So this is the problem you have to solve. Now you see this is the first problem. Problem number 1. Y is equal to tan inverse x. This is the function, inverse function. So y is equal to tan inverse x. Now you are differentiating this y, that is you are operating ddx on this y. So what will you get? Dy dx is equal to ddx on this tan inverse x. That is we are operating ddx on tan inverse x. Now you recall what was the derivative of tan inverse x? See your formula, 1 by 1 plus x square. So this 1 by 1 plus x square, this is the first derivative. That is you are getting the first derivative, y1, something like this. Now a very important thing. In the second derivative problem, always you will find that there is some u by v function. Here it is 1 by 1 plus x square. This is the v, 1 by 1 plus x square. 1 plus x square is the v part, u by v. This is the first derivative. Now, as we know, or you know, that when it is ddx of u by v, it is easy to differentiate this u by v function than to differentiate u by v. This formula is little bit critical. But the first derivative of a product function uv is very simple. Like first unchanged derivative of second plus second unchanged derivative of first. So that is as simple as this. So to find the second derivative problem, you have to make it a uv function. Now how you can make it a uv function? Just look, this 1 plus x square in the denominator, if you cross multiply it, then you will get this 1 plus x square multiplied to this y1. One plus x square multiplied to this y1, that is the derivative dy dx. This multiplied by this is equal to 1. So just we are multiplying this on this side. Now you got a uv function. This is your u function and this is your v function. Now your job is to differentiate this again, because we are going to solve a second derivative problem. So how you can do that? Just use this formula. ddx on u by v is first derivative, first unchanged derivative of the second plus second unchanged derivative of the first. And we are applying this. First unchanged, that is 1 plus x square. This function is u function. This is unchanged here. Now derivative of second. Now ddx of dy dx, I have told you ddx of dy dx is nothing but second derivative. That is dy by dx2. Or you can write it as y2. You can write it as y2. So 1 plus x square multiplied by y2, first unchanged derivative of second plus second unchanged. Now this is the second function. This is unchanged here. Now derivative of this first function. Now what is the derivative of first function? Derivative of 1 is 0 and derivative of x square is 2x. So here it is 0 plus 2x and that is 2x. So that is equal to ddx on 1. Now you are differentiating both sides. So you should differentiate 1 also. Now what is the derivative of 1? 0. Because derivative of any constant is nothing but 0. Derivative of any constant c is 0. And therefore this part is 0. Now look, this is nothing but the solution. What was the problem? 1 plus x square dy by dx2. Now here it is 1 plus x square dy by dx2 plus 2x. Here it is 2x multiplied by dy dx multiplied by dy dx is equal to 0. So this is your answer. So this is the first problem. Now I think you understand this. Now I will be moving to the second problem. Now the second problem. Now here is the second problem. Problem number 2. Now this is a problem on sine inverse x. Now you should understand what is the derivative of sine inverse x. So y when differentiated, it gives 1 by root over 1 minus x square. This is the first derivative. I told you have to remember the first derivative of all the inverse. Now the derivative of sine inverse x is 1 by root over 1 minus x square. Now the problem here, the second derivative problem here is this one. 1 minus x square multiplied by dy by dx2 minus x multiplied by dy dx equal to 0. This you have to prove, second derivative problem. Now how you can do this? I have told you in all cases you will see here u by v form, but we don't like this and therefore just bring this to that side. So this will become this and this will come to here. So root over 1 minus x square multiplied by dy dx is equal to this 1, is equal to this 1. Just what we're doing, we just cross multiply. Now look, the first in the first problem, in the left hand side it was just 1 plus x square, but here we see there is something in the root over. Now this root over is making problem because it is difficult to differentiate a root over thing. So for that you have to do the second tricks. Now what is that? Just squaring both sides. While you will see that there is some root over, you must square it, and you should square on both sides. So this is 1 minus x square multiplied by dy dx whole square. When you are squaring this root will vanish and this will be square. So that is equal to 1 square, and that is 1. So now it is this line. Now to solve this second derivative problem, you have to differentiate it again. And here again, you see this is u and this is v. So this is the first function and this is the second function, and that is equal to 1. So you should differentiate it again by the same formula, ddx on uv. And now also we know first unchanged. So first is this one, 1 minus x square. This is unchanged. Now derivative of the second one. Now what is the derivative of these things? This is very important. What is the derivative of this dy dx whole square? Now look, this is a very important step. ddx on something x square. What we write? We write 2x. This is the derivative of x square. Now treat this as x square first, because this is a function of function. So this is one function is a square function, and the other function is, this is not x actually, this is dy dx. So this is function of function. Now how to differentiate this function of function? You have to apply chain rule. Chain rule is important here. Chain rule, that you have to apply. Now if it is not x square, then you have to differentiate it again, it as x square. So what will be that? 2x. Now x is dy dx here. This dy dx we are treating as x. Therefore, this is 2x. But as I have told you that you have to apply this chain rule, because it is not x actually. It was not x. It was dy dx. So you have to write a chain, and we are writing a chain here. Look, chain means into. Into what? Now into this derivative of this thing, this inside thing, which you treat as x. Now the derivative of the inside thing, dy dx, derivative of dy dx is nothing but d2y by dx2. First unchanged, derivative of the second, plus second unchanged, dy dx whole square is unchanged, and the derivative of the first part is, derivative of 1 is 0, and derivative of minus x square is minus 2x. So we are writing here minus 2x. And that is equal to derivative of 1. And what is derivative of 1? It is 0. So you see, this 1 minus x square, I'm showing you. This is 1 minus x square into 2 into dy dx into dy by dx2 plus dy dx whole square into minus 2x is equal to 0. So this is the equation. Now it has come. But you have to prove this one. Now this is 1 minus x square. Now look, this is 1 minus x square. Now here it comes 1 minus x square into d2y by dx2. Now here it is d2y by dx2. But you look, this 2 into dy dx part, this 2 into dy dx part is not here. So what we can do, we should divide this whole thing by dividing, I'm written it here, dividing both sides by 2 multiplied by dy dx. Because this 2 dy dx is excess here. There is no 2 dy dx. So this is excess. So you should divide this by 2 dy dx. Now look, if you divide this by 2 into dy dx, in the first part, this will go. So you are left with 1 minus x square into dy by dx2. Now this plus and minus will make you minus. Now 2 dy dx, you are dividing by 2 dy dx. You are dividing this part, you are dividing this part, you are dividing this part. So when you are dividing this part, this 2 will go and this dy dx 1 will go. So you will remain with minus of x into 1 dy dx, x dy dx. Now when you are dividing this 0 by 2 into dy dx, because you are dividing both sides by 2 into dy dx, so here also you should divide this by 2 into dy dx. Now 0 by something is nothing but 0. So the answer is this one. So